In addition to providing the community a solid software development platform with ROS, we also want to provide a solid hardware development platform. As Steve Cousins introduced, we hope to see the personal robotics industry in the future be a healthy network of platform providers and application providers similar to the computer industry today. The PR2 robot is a development platform in that model. The PR2 robot is designed from the ground up to be an awesome developer platform. The hardware is modular and the interfaces are open. We have just started production of the final PR2 robots. These are photos of some of the first production parts off the line. The rest of the photos and videos you are seeing of PR2 in this presentation are alpha level prototypes that we have been using at Willow Garage over the last year. I want to take you through some of the features of PR2 systems. Beginning with PR2's onboard server. Again, this server was selected to be a robot software developer's dream. The PR2 server is an 8-core i7 Xeon system with 24 gigabytes of RAM and 2 terabytes of hard drive capacity. And there are 2 of these servers on board PR2. PR2 servers let developers take full advantage of ROS's distributed architecture. Not only does PR2 have a lot of onboard computational power, but it also has a full suite of sensors to enable a wide range of capabilities. First, we start with a planar laser scanner in the base for navigation. Moving upwards, there is a tilting planar laser scanner for generating 3D point clouds. On top of a generic pan-tilt platform on the robot's head, there is a 5-megapixel camera for getting high-resolution images, a wide-angle color stereo camera for getting full frame rate 3D data from the environment, and a narrow stereo camera paired with a textured light projector optimized for manipulation tasks. There are also cameras in both forearms that provide a close-up view of the gripper, and the gripper tips have pressure sensor tactile arrays that let the robot pick up an egg without breaking it. I've talked about PR2 sensors and computational power. Now I'm going to talk about what the rest of the robot can do. PR2's arms are mechanically backdrivable and current controlled, which gives PR2 the ability to exert only the forces needed to effectively manipulate an object. Even at its stiffest settings, PR2's arms can be overpowered and backdriven, which is especially important when interacting with people. PR2's arms enable PR2 to interact with the uncontrolled environments of the real world, environments that may not be well modeled, but can be manipulated with a backdrivable, compliant robot. And with 2 arms and a mobile base, PR2 can perform complex tasks like opening a spring-loaded door, taking the top off a bottle, and opening a binder. We believe that PR2 is a very capable robot, but by no means do we think that it is perfect. That is why PR2 is mechanically modular. PR2 has sensor mounting points, electric power, and Ethernet on top of the head, on the shoulders, in the base, and in the forearms for sensor expansion. You can remove PR2's grippers, mount specialized tools, or other grippers. You can also remove the forearm and put on a different forearm. Or you can remove one or both arms altogether. Of course, you can't use these capabilities unless the platform is mechanically robust. We want developers to be able to focus on developing and debugging their software, not the hardware. To achieve our goals for reliability, an aggressive testing program has been an integral part of the PR2 design process. Here are some videos of early subcomponent testing for PR2 subsystems. Each subsystem on the robot has literally seen thousands of hours of abusive life testing in its design cycle. PR2's arms and the full robot have also seen thousands of hours of testing time. Our testing program was designed to simulate, in an accelerated fashion, the abuse that we were seeing our software developers put on PR2. I've been talking about PR2 being a robust and capable developer platform. Now I'd like to show you a couple of video clips from some of what Willow Garage employees and the more than 50 visiting roboticists to Willow Garage have built with PR2 and ROS. Arm path planning while holding objects. Planning in the presence of moving obstacles based on sensor data. Smartphone and web interfaces for controlling the robot. Integration of ROS with the Irokos RTT real-time framework. Image processing and object recognition, including structure from motion. Segmentation of 3D point clouds. Model fitting. And object labeling. Manipulation tasks, including grasping based on sensor data, basic game playing, and some simple cleanup tasks. Plugging into a standard wall outlet, and navigation in changing 3D environments. To review, PR2 is designed with ROS to make the code writing experience for personal robotic technologies and applications easier. It is robust enough that you can develop and test code on the robot itself, and it is ready to develop on out of the box.